Welcome back to Algebraic Expressions and Equations, Part 2. We're going to look at adding and subtraction with an algebraic expression or equation. But first we're going to double back to looking at just if we had real numbers. Now, algebraic expressions, variables take the place of real numbers. So everything that we would do with real numbers, we can do with an algebraic expression that may contain an x or a y or an a or some variable value that takes the place of a number. So we understand 9 plus 1, well, that gives us 10. We've learned that. But also, if I had 9a plus 2a, that would give me 11 a's. Again, because a takes the place of a number, we can just add 9a's to 2a's to give us 11a's. And if I had 3x minus an x, I'd be left with 2x's. So the same would work with subtraction. And that's because the rules for adding and subtracting of real numbers would apply even if there are variable values that we're working with. So 2a squared x plus 3a squared x, since these look identical, they are similar or like terms and I can add them together. So altogether now I have 5a squared x's. Likewise, if I have 6b c to the third and I take away 2bc to the third, I would have 4bc to the third. But if I had 2ab plus 3ab squared, that is as simplified as I can get because ab is different than ab where b is being squared. So that's as simplified as we can make it. Now, there might be some confusion. When I talk about an algebraic expression, it would be this right here is an algebraic expression. I took that expression and I simplified it. That's why you see that equal sign. I took the 9 and the 2, added them together to show that I had 11a. This is not an equation. I'm not solving for a. So when I start out with something like 4ab c to the third plus 2ab minus ab c to the third, that's an algebraic expression and I can simplify it. When I simplify it, in other words, if there were like terms like I see right here, abc to the third is the same as abc to the third, I can simplify that. That's where I would put the equal sign in to say that this statement is equivalent to 3ab c to the third plus 2ab. So please don't get confused when you see the equal sign. If you begin once again with an expression like 5xyz plus 2xy minus 3xyz, that's an algebraic expression. And I would ask you to simplify that. That would mean that you would look for like terms and simplify them. In the process of simplifying them, you would look and note that these two are the same, and then you would say, I'm now going to write an equation, a expression that is equivalent to this. That's why you put the equal sign, and you say that there are now 2 xyz's left plus a 2xy. These two expressions are equivalent, which is much different than an equation where you're solving for a variable or variable value. For example, if I had 2x plus 3 equals 6 and I start out with an equation, this is an equation because you see an equal sign, I could ask you to solve for x. And you would use rules and principles to solve for that x. So please don't be confused between the two. Right now we're dealing with algebraic expressions and how to simplify them using addition and subtraction. So let's begin. Let's begin, as we started before, with just simple addition. We know that if I do 20 plus 3, I would get 23. And if I had 20 and I take away 2, That would leave me with 18. But I will contend that this statement right here is equivalent to 20 plus a negative 2. In other words, 20 minus 2 is the same thing as adding 20 plus a negative 2. So a negative 2 is the same thing as subtracting a 2. Both of these would lead with 18. And how you think about it might change in a particular situation, but how you handle it obviously remains the same. So I could see things like negative 6 plus a minus 2. What do we do with that? Well, there are rules that we can follow. If in addition, both of my numbers have the same sign, I add their absolute values. So I add the absolute value of negative 6, which is 6, and the absolute value of minus 2, which is 2, and I add these to get 8. But since both numbers were negative, my answer would be negative. Now, if I had negative 6 plus 3, the signs are different. Then I would take the absolute value of the larger number, that would give me 6, and I'd subtract it from the absolute value of the smaller number, which is 3. And I would subtract these two numbers. Then, when I give the answer, the sign that I would give to the answer would be the number that has the greatest number. I would look at its sign. So since 6 is the larger of 6 and 3, it had a negative sign. My answer would be negative 3. That's one way to look at it. You could also think about money. If I owed $6 and I paid the person $3, would I still owe them money? Sure thing, I'd owe them $3. So there's lots of different ways you can think of negatives and working with them when you're doing addition. And of course, subtraction is only addition with a negative number. So all these rules would apply. So we can look at all the different situations. Negative 6 minus 2. Well, that's nothing more than what we saw up here, because we could rewrite this as negative 6 plus a minus 2. Or one could think of, I start at negative 6 and I go 2 more away. I get more in debt by 2. So again, I'd be at minus 8. Now with small numbers like this, it's no big deal. But if you have decimals or fractions or larger numbers, knowing some of these rules are nice. So if I had a negative 325 and I want to add to that 50, well, I could use my rule where I know my answer is going to be negative because my bigger number is a negative number. And I could think if I was in debt, $325, $50, it would put a dent in it, but not that big. I'd still owe a lot of money. So how do you find out how much you owe? Well, we could use the absolute value trick where you take the larger number, take its absolute value, the smaller number, its absolute value, subtract the two since their signs were different. And that would tell me that I have a negative because my bigger number was a negative number, negative 275. And again, I could use that with fractions. If I had a 3 over 7 minus a 6 over 7. And we know the rule of fractions, that if I have a over c plus b over c, I could rewrite that as a plus b with its common denominator of c. This only works if I have a common denominator. And likewise, if I had a minus b, of course both of these being over c, it would be a minus b over c. But once you knew this, since subtraction is only adding a negative number, it would have applied to this rule anyway. So in here, I have 3 minus 6 over 7. My bigger number is the negative number, minus 6. So I take its absolute value, which would be 6. I subtract it from the smaller number. I would have a 3. But my numerator, since the larger number had the negative sign, I'd have negative 3 over 7. Now, why do I do this? Because I can add x's and y's and variables to this, and everything would still stay the same. So let's say I have minus 7x, and I'm adding 5 x's to it. Since these are similar, in other words, these are like terms, they're both x's, my larger number being a negative number and my smaller being a positive number, I subtract the two absolute value. So the absolute value of -7 is 7. The absolute value of 5 is 5. And I subtract those two to get 2. And my answer is negative, since my larger number had the negative sign. So I'd have -2 x's. So what applied to just regular real numbers would apply to expressions with variables. So if I had 5x plus a -2x, well, 5 minus 2 is 3. I'd have 3 x's. If I had negative 5ab plus a negative 12ab, that would give me negative 7ab. Since my numbers had the same sign, they're both negative, and I'm adding them together, and they both have the same exact variables in there, they're like terms. So I add them together, keeping their sign. So if I had 6a squared b plus 3a squared b minus 2a, if I simplified this expression, that is, give an equivalent expression, that's why I put the equal there, I see that these two are like terms. And that's a positive 6 plus a positive 3. So I have 9a squared b's. And I can't do anything with the 2a. It doesn't have a like term, so it just comes along. So if I had an algebraic expression like 3ab minus 2 times 6a minus 2ab, and I said simplify this expression, and it has parentheses, and we know our order of operation is go inside the parentheses. Well, since 6a and 2ab, the negative 2ab, they are not like terms, I can't do anything, so that means I have to distribute this minus 2 inside the parentheses. So an equivalent statement to this would be 3ab minus 12a plus 4ab, because negative 2, this negative 2 times 6a gave me that negative 12a. The negative 2 times this negative 2ab gave the positive 4a. But I'm not done yet, because if I look here, I see that this and this both have an ending of ab. They are like terms, so I could add those. So not only is this an equivalent statement to my original statement right here, but this one I'm going to write right here, 7ab minus 12a. These three statements, this statement, and that statement, are all equivalent statements. So that's how we work with adding and subtracting of algebraic expression. Thanks for watching.